Hey everyone, it's been such a long time. Life has changed a lot. I'm living in Madrid now. I've been living in Madrid for a while. It's no excuse, honestly. I've been trying to make this tutorial for a very long time, but hopefully this time we'll make it happen. Making a game in Unity, yeah. I'm doing a master's in game development here, mostly focused on what is Unreal Engine, but we have had to see a little bit of Unity as well. And I'm a bit of a specialist in Unity through the years, I suppose. Never fully got taught, but I guess you learn by experience. And I've been realizing how there's a little nuance there that people don't know how to teach. And I'm no teacher, personally. I mean, I've tried. Like, when you start making a game, how do you even evaluate the project? So I just want to do something very, very slow to start people into the engine and maybe make a small project that might help them. What do? I'm Bernardo del Castillo. I'm Raptors Games. I make smallish indie games. My last game took 10 years, so that's not smallish. And now I've been working on a master's and I've just developed games. I'll show them here, maybe. You can always message me if you have any doubts or anything, and I can help you out. So this is probably going to be a pretty basic introduction to the Unity engine from a very holistic side and focusing more on the programming aspects. It may grow to be a full-blown tutorial depending on how it goes, but I might shape it depending on the feedback I receive. I think that for this project, what I've planned is to make a little simple asteroids game, sort of, but with more mechanics that you might be able to extrapolate to any other type of game that you want to do. You don't need a lot of programming knowledge, but hopefully there's some understanding on how that works. Most of the early videos, I'm planning to make this a series, but there'll be more with the UI and the functioning of the engine as a concept. So what is Unity? It's a game engine. That means that it provides kind of tools between a developer and the final product to create video games. It is programmed in C++, but we luckily can use the very lovable C# to program in Unity. Also, basically to script. It's mostly free, but if you do want to publish your game to consoles, you need specific features and you will probably require a pro license, which is over $1,000, so good luck with that. Yeah. Well, $1,000 a year. In any case, it is a very flexible and powerful suite of tools. I will not speak ill in that sense. And because of how easy it is to start and to play around with it, it's I would say that it's the favorite for prototyping and game jamming. Godot is sort of getting up there. Unreal is trying to with the blueprints. I don't see it happening anytime soon. Unreal is I don't know. I've got thoughts about Unreal for another day. To start, you're going to need to make yourself an account, of course, because everyone loves an account. So probably you're going to have to go into the Unity 3D, well, not even Unity 3D anymore. This was not necessary back in the day, but nowadays you do. So who doesn't love accounts, yeah? And then I'd recommend you download Unity Hub. I don't actually know if this is optional anymore. Also, Unity Hub is sort of like it's a little platform where you download different versions of the engine. It didn't used to be required. It can be a little bit confusing, but it's the way that they've gone. It's very similar to what Unreal does. They sort of copy each other in weird ways. Not the best ways, but I don't know. You do you, game engines. If you want to play around with more advanced features and whatever, you can download the beta or the newest versions. We are probably not gonna use the latest version. I'm not exactly sure which one we're gonna use. I'm gonna check. Give me a second. Let's actually look at it. me see. Gonna open up the Unities. This is Unity Hub. And you can see, like, it might start here. You want to go into installs and see, yeah, you might require to install an editor. I would recommend an LTS, long-term support, I believe it stands for. Any of them will be fine. Generally, I go with the 6.3. It's the current LTS. But yeah, if you see like a newer number, that's fine. You can pick that one as well. Generally, within a large version, things don't change hugely. You can pretty much be safe in a project. So once you select and download that engine, you can go into projects, and we're going to create a new project. I've got a ton of different projects here, but we're going to make a new one. You can select the version that you want. You can select the type of project. I would say right now, the safest one to use is a Universal 3D, but it's not all that important. You can like modify the project later on. We name it Asteroids. Now we're gonna save it in our work project. We're gonna create a new folder. We're gonna name it Asteroids tutorial. And we're gonna save it here. Asteroids. Okay. Asteroids. Yes. I will select that folder, and with that, we're ready. We don't want to use Unity version control unless you're working with a team. That's a little bit of a tricky setup anyway. And it will be creating our project and opening it up for us. There are a few different things in Unity that lets you pick. Currently, there's a division between like URP, which is Universal Render Pipeline, and HDRP, which is like the High Definition Render Pipeline. It was supposed to be that like for high-end products, you would use the HDRP, but to be honest, it's buggy as hell, and all of the features are weird. They're not very performant, so I would stay away from the HDRP. There's also the built-in render pipeline, which is the older render pipeline. It doesn't have any of the like newer features, but it does have a lot of flexibility. So if you want to like code shaders and do your own thing, it might be an option sometimes. URP is generally the standard now. It allows you to be pretty performant, and it does feature a lot of new. I mean, most people have started developing for that one, so you might as well pick that one. In the future, it seems that Unity is actually gonna remove all of that, and we're gonna just have one render pipeline, which honestly good, because this has only created a lot of I don't know, turmoil between developers, and they've never felt like fully featured other than the URP. So we're waiting on the projects to start. Look, I wore my very fancy turtleneck for you guys. My fanciest turtleneck. It's fucking cold in Madrid. Oh, that's nice.
One hour later.
It generally doesn't take this long. It's probably the first initialization.
6 months later.
Oh, we're done. Okay. So anyway, this is the Unity editor. Welcome. There's a lot of confusing things about the user interface in Unity, and I won't go through all of them today, but what you should know is that, like, here's the hierarchy. This is our scene. The Unity works through scenes, and this is our open scene, our very first scene. Here below is our project, and basically these are our files on our system. This is a copy of files that are actually in your computer. And here's the scene view, where you can change things, move things around. And if you select anything, either on the scene hierarchy or on the scene view, the inspector will show you the properties that it has, right? There are some things that you can change, some things that are static. We will learn more about that. Here in the scene, you can also notice that there's a tag that says game. This one you can't really modify. This actually just shows you what you would see in the game. It's often good to have them separated. I prefer to have them separated. So basically one game view and one scene view. I also prefer to keep the aspect ratio locked to 16:9, which is generally the one that you're going to be using. But yeah, if you want more specifics about the user interface in Unity, we can do another lesson, maybe. Let me know. It is fairly deep, and there's, like, you can see here in the window tab up top and the menu, there's a ton of different, all of these are different viewers and different properties that you can, like, show up. And it depends on what type of game you're making. Some of them you'll never need. Some of them might be required. Like, yeah, it depends. It's a pretty robust engine, so it's expected. Also, just so you know, there will be probably a presentation coming up. I'll try to host it in my website with all this information sort of more digestible, more succinct, without me rambling a bit. I'll try to make a few slides for just examples, so you can check it out there instead of, if you don't want to hear my annoying homosexual voice. So we have a general overview of the editor, and we will come back to it to see more in depth later. But for now, I want to go into more like the theory of how Unity works, right? The structure of the engine. You have a game that's your product, that's your overarching product. And this game has a name, has build properties, has settings, and it has scenes. That's the way that Unity works. There's no kind of one project overall. There is, technically, but it works through scenes. Scenes are mostly defined by a name, an ID, and they have a few other defining properties that we probably won't be seeing here. But the thing is that they hold game objects, and they hold the objects that you will interact with in the world in your game. It's not exactly as clear as that, but that's mostly how you'll interact with it. And then we have the specific game objects, which are these more modular components of your game. And they're more specific. So they have a transform, they have a name, they have a tag, they have a layer. They can have a lot of different properties. And they can also have components, which are either defined by the engine, like colliders, renderers, rigid bodies. And then they have monobehaviors, which are where we are going to go in as programmers. These are basically behaviors. These are scripts for the objects. There's other types of game objects now. There's the Unity Entity System, which is a little bit more complicated. It's used for very high volume objects. Basically, if you wanted to have thousands of bullets, cars, spaceships, and they don't quite use the same model as the game object. They're not entirely separated, but they work in a completely different way. But we won't be touching those. Those are a little bit more complicated. They don't have such a clear user-facing interface. So, for the future. So here's kind of what I was saying. This is the general structure of Unity. We have a project, a game with all the properties, the build targets, the scenes, just our big thing. Then we have a scene with our light data, with embedded assets, with a lot of different things. And then we have our game objects with our components, our monobehaviors. This is just a kind of an abstract view of the structure. So let's look at how do we create a monobehavior, basically a script for an object. First off, we're going to go into Unity, and we're going to go into our sample scene here, and we can either right-click on the empty space or just press on that plus button. And we're going to go into a 3D object and create a cube, right? It will take a second. Here's our cube. It is blue for me initially because it's compiling the shaders, but it should be fine. Okay, now we have our cube. So if you select the cube, you can see on the right side on the inspector that it has a name, it has a little tick which enables it and disables it. It can be set to static or dynamic. It has a tag, it has a layer, it has a transform. And yeah, all of the different things that we spoke about, like these are the things that can be held in a game object. And for now, the way that we're going to do it is in the assets folder, we're going to right click and create a new folder. We're going to call it script. This is basically creating a new folder in your Explorer, like in your computer. I'm just doing this to keep it organized. You could do it without. And we double click on the scripts and we create a monobehavior script. And we are going to call it rotate. This is a stupid script to do, but we're going to do it anyway. Now we have a script called rotate. The engine will probably reload domain, which means that it's actually compiling the script, making sure that it runs. And now that it's an empty script, it doesn't do anything, we're going to drag it to our cube. And now you should see it, when you select the cube, you should see that it has our new rotate component down here, right? We've created our first monobehavior. There's many different ways to do this. This is the more clear way for me to explain it. Now we can double click on rotate. And, well, this is where you probably want to have an IDE, some place where you code. And this is our very first monobehavior. It creates this by default. I hate it. I don't want nothing of this. I delete the whole thing. I just keep the monobehavior. But we'll come back to this. Let's continue with the overview. So in a monobehavior in our scripts, Unity will, by default, run a bunch of things for us because it knows that we want to do something with it. The most common ones are start and update. Basically, it lets our script know that the game has started running, the start. And update updates every frame. And that's basically how games work overall in every engine. This is the structure of games. We simply have a loop that's constantly running. The structure of the loop is a lot more complicated than this. There's a lot of different instructions that Unity runs every frame. But this is our basic function. So every monobehavior will have these available to them, and it'll call these functions depending on what's required. So, for example, when our monobehavior is loaded into the scene and is ready to use, basically it'll call awake. And we can use this for certain initializations. More often, start is used. It just happens a little bit later. So yeah, it depends. Sometimes it has more of an impact in like memory load. So you might want to like stagger those depending on how required they are. Often, like a manager, like a big class that will be important for your game might want to be instanced or initialized on awake. And later on, you can have like smaller things. It depends on the structure of or the architecture of your game. You might not want to start anything at that point. You might want to start very slowly loading things. It depends. And then there's the update loop, which is basically the building block of every game. You have a loop that's running every frame of your game. There's a few different types of update in Unity, which are sort of important. Update runs every visual frame. And then we have a fixed update, which actually runs more times. It calculates physics, so it has to be more consistent. And for example, for other things like animations, there's late update. So you want to update after everything has been sort of calculated. Yeah, there's specific situations in which you might want to use them. We will see why and when we will use each one of them. For this, we're actually not gonna create a start. We're just gonna create an update for our rotate class. We're gonna create a variable, float, a public float. And in our update, we will go game object, which basically references the current game object that holds this mono behavior. Form dot rotate. We're going to say we can pick the function we want. We're going to say axis angle, right? So we're going to say vector3 dot up and rotation. It's a little bit complicated, maybe. Depends on how early you are. But we'll explain it. So now this actually should work already in some level. It'll recompile our mono behavior. And our cube, which has our rotate script, we can actually press play. You'll see that rotation is at 0 right now. That's fine. We'll see how this works. And so it's at 0, but we can put like 0.1 now, and you can see that it starts rotating. We can put 1, and it basically is rotating 1 degree every frame. So that's good and all, but this will have a lot of different problems that we will see later on. If we want to put 10 degrees, yeah, you can see it works, sort of. Yeah. Let's go back and sort of understand what we're doing here. So first of all, let's just look at variables and what variables we can have in mono behavior. This is very early programming. Like, basically, variables are any component that you might need on your class that you want to initialize, that you want to use in any way. There's more, but there can be public, private, and protected. In Unity specifically, public variables are quite useful because if it's a standard type, or if it's serialized with standard types, it will be visible in Inspector. Basically what we did with the rotation. If you remember, in our class we set it to public. That means that it is visible. If we instead set it to private and save that, you'll notice that the rotation will disappear from our rotate script here. I duck. See? Now we don't have rotate. There are also other ways to do this. You can actually serialize the field if you want, and that'll force Unity to display it even if it is private. A lot of people recommend this for data security. I find that it's a little bit confusing, especially if you're starting to have all these tags and stuff. So I like to keep, I know that it's maybe a little bit messy, but public to me is very clear the way that it works. So yeah, it will expose it in Inspector. Private will do the same thing, and it will not be accessible by other classes, even if they have a reference to your class. And protected will only inherited classes will have access to this variable. There's many types of variables that you can have. There's ints, there's floats, there's strings, game objects, transforms. Honestly, any mono behavior or component or any standard library classes will be available. Some of them are not. Some of them Unity does not have a standard method to display them if you made them public, but you could always even create like a structure or something like that that would hold them and then feed them. It's up to you. It's up to your programming skills or requirements. Often with the basic, it's more than enough. Another important thing of the Unity engine in general is that it has a lot of different engine callbacks. We already saw the basic ones: awake, start, update, fixed update, late update. Those are engine callbacks. But there's also more specific ones depending on what you want or what you have enabled on your mono behavior or on your object. For example, the basic ones, they're like on enable, on disable, on destroy. These respond to what you would expect when an object is enabled or disabled in game or by you. It might call those functions. If you have a collider attached to your game object, it'll also start receiving these callbacks, which are on trigger enter, on collision enter, on trigger exit, on collision exit, on trigger stay, on collision stay. And I don't know if there's any more for colliders, but it basically allows you to have more functionality. And also, if it has a renderer, you can also use the on became visible and on became invisible, which often is useful for optimization purposes. I will say those are a little bit finicky because sometimes the editor cameras do count as on became visible. And also, if it's being rendered for shadows, it might also still be rendered, even if you don't quite see the object on screen. So yeah, there might be better ways to calculate the on became visible and on became invisible. But anyway, there's a ton of different engine callbacks, and they're all quite useful depending on what you need. I think that we won't be using any more than these that we have here for this project. You can do a lot with these. So for example, if we wanted to do something at the start of the game when we press play, we can hook our mono behavior to the start function. Start. No. And you can see that it creates a method for us if you have Visual Studio. It works really well with Rider as well if you have the plugins. And let's say that we want to game object .transform.rotate. Rotate. Sorry. We're going to do the same thing, but we're doing it in a different angle, I suppose. We're going to say vector3 dot right instead of up, and we're going to rotate it by 100 degrees. You want to make sure that when you use numbers, you generally use floats. If you just do 100, it'll consider that to be an integer, basically a number without any extra decimals. If you do 0.0, it'll think that it's a double. It has a lot of precision, but it's very expensive for our system. We don't need it. So the way that Unity, and I think that's just C#, we use Fs, which are kind of shorter versions of a number with decent enough precision, so it shouldn't be a problem. It does become a problem with some situations, but we're probably not going to head into those. And so what we should see here is that when we start the game object will rotate on its right axis 100 degrees, and then it'll start rotating on the vector up by the rotation that we said. Okay. So let's see if it works. Well, currently we have 0 rotation. Let's set it to 10 or to 10 and just see what happens. See, it kind of tilted by 100 degrees and then it started rotating around its local axis actually, which is not exactly what I expected, but it's fine. That works. How can we make it rotate around the world? And that's another. This rotate function has a lot of different versions. So space relative to. So we can actually define space dot a world. Basically now, instead of saying that it rotates around its own vector 3 up, it'll rotate around the world's vector 3 up. So now we should see a bit of weirder of a rotation if we play. It'll do the 100 and then it should rotate around the top. See, now it's wobbling kind of through. that, which is exactly what we wanted. Anyway, what is the issue with this? This is actually frame dependent. If we have really poor frame rate, it will still rotate those 10 degrees every frame. And that means that a very high frame rate will rotate much faster than a low frame rate. This is the infamous issue that they had in Dark Souls 1, where like durability for weapons was frame dependent, so having low or high frame rate affected how poorly your weapons would degrade. So we want to kind of account for that. What happens is that in games, every frame is actually different. The timing is, it's not hugely different, but depending on if you're loading things, if you're, I don't know, creating some very complex scenery, having some calculations that are difficult, you might see a significant amount of variation depending on what you're doing. So we can't have this rotate by basically a static amount, because this error will accumulate and you will notice it. In this case, often what you do is use something called delta time. Basically, it is the time that happens between one frame and the other one. And Unity already has that added in, delta time. So we will multiply the rotation that we're adding times time dot delta time. Okay. And that should basically give us a more consistent, it still has issues, but it's a more consistent rotation. It'll help us make sure that our rotations are not like completely out of control. And you'll see now that we're multiplying by a very small number, because delta time, imagine how small it is. Every frame, basically it's a 0.03, I believe, around, it's 60 frames per second. So you can see that it now rotates very slowly, but if we do 1,000, it's rotating pretty fast now, it should be more frame rate independent. It should not depend on our frame rate. It should still be rotating at the same rate for any computer, basically. Don't trust me. Don't trust the engine. Okay, that'll be probably it for our introduction, and we will continue on the next video where we will create some inputs and some movements for our character. That will be a little ball to start with, and maybe some asteroids that we might or might not be able to shoot. Hopefully this was somewhat useful. It probably is quite short and quite basic, but still, if you have any questions, just let me know. I'll be here. I have way too many projects, but I probably can sneak in some time. And yeah, let me know if this is helpful at all, or what you'd like to see, if there's anything specific. And yeah, see you in the next one. Hey, you got no more excuses. Go make your fucking game now. By the way, I'm no YouTuber and I'm not very good at speaking live, so this will take a while and there'll be no funny business, okay? If I see any funny business, you've been warned.